Ladies and gentlemen, our panel discussion now is titled Technology That Powers the Future. Our panelists are Rami Qasem, Executive Vice President and Chief Commercial Officer, Beyond Limits, and Dr. Nima Golsharifi, Chief Executive Officer, NDB. And our moderator is Raif Asiri, General Manager of Market Development and Local Content, MCIT.
Doesn't matter.
Our distinguished guests, ladies and gentlemen, thank you for joining us in this panel. And I'd like to share that this is particularly special for me. Rami, I know you since 2016. We had worked together before. I had the privilege to work with you at GE and Baker Hughes. Nima, I know you since 2010. And we worked together at the London Center for Nanotechnology in London. So this is truly a special moment for me that I'm reunited with you here in Riyadh at Tech Expand. Thank you for joining us today.
Thank you. Thank you for having us.
Thank you, Rami. Thank you, Nima.
Thank you for the invitation.
Our topic today is about a technology that powers the future. And I think both your experience, Nima, and your experience, Rami, share a unique and interesting perspective on this topic. And I'll start with you, Rami. You're an energy industry veteran with multiple decades under your belt in the industry, and now you're a global executive of one of the prominent AI companies globally. How do you see the role of technology in transforming the industry today? What it was before and what it is today, and how technology helped make that shift?
Thank you, Raif, and it's a great honor to be here and partner with you and with all of the colleagues in this very prestigious, I would say, event. Some of us maybe have few years under our belt. After 27 years serving the energy industry between oil and gas and power generation, I'm one of those who have to go through Y2K. I'm one of those who used to go and try to sell a software for a refinery or for a chemical plant as one of the first when it comes to machine learning or comes to predict and read what's happening inside the machine, and then you end up what at that time we used to call dusty keyboard syndrome, where people buy the software but nobody touched the keyboard. And if you think about the last 25 years, where we were and where we are today, I would say the industry evolved and primarily the user themselves also evolved. So from my perspective, the energy sector in particular have been through multi-phases, but believe it or not, they were one of the first to try, to experiment, to learn. And with time, we move from only looking at what's happening inside the rotor to understanding how the total plant or asset behaving and to where we are right now.
Fantastic. So the role of leadership in large enterprises, in energy sector or in any other sectors, is a pivotal factor in transforming these companies, right? So if the leaders are willing to adopt technology and becoming first adopters and trying to incorporate and implement these solutions within their day-to-day operation, then the overall enterprise and organization would shift and transform into a more digitally advanced state.
Rightly said. It's all about the mindset, it's all about the leadership, and it's all about the willingness to adapt and change. I mean, just think over the last 5 years. Look at how the transformative been the entire sector and what you have seen in the kingdom and so on. And I would say in any industry, in any company as well, equally, visible from the leadership. If the leadership adopting to change, adopt and embrace technology, embrace innovation, it will become part of the DNA, is part of the culture, and we have seen it in many corporations, no matter how small or big. I think that's fundamental to your point.
Nicely said. Nima, I'll move to you, and I think we'll start with a very simple question that a lot of us here today, or the people that are watching us, maybe are hearing about for the first time. Nano diamond batteries. This is a fascinating and amazing concept. We'd like you please to tell us more about nano diamond batteries, how they work, what the concept behind it is.
Sure.
So all of us are with you on the same page, or at least we will try to be.
Yeah, I tried to go like very simple about it at the beginning. So what we try to use as a resource is nuclear waste, and this nuclear waste holds radioisotopes. So these radiochemicals or radioisotopes are being used, and we are trying to use a transducer. So it's a kind of a semiconductor material, which try to capture the energy through the ionization process. So as simple as that, but I can get deeper and explain a little bit more now. The technology is quite similar to solar cells. The main difference is that we're using, rather than the sunlight, we are using the radiation from these radioisotopes. So it has a couple of benefits. One is that they are climate independent. So if it's dark, it's still working, so we don't have that issue. And the other interesting point is that most of these isotopes, not all, have basically higher longevity than the others. So you have the half-life, and it can be from few years to thousands of years. So that means we can reach a lot of interesting applications, which can go up to thousands of years. So that's basically interesting part about this technology. There are different mechanisms that we can use to harvest the fast electrons within this technology. One way is basically passing these electrons through a semiconductor, which basically slows them down. And when we are slowing them down, we are able to convert the kinetic energy to electricity. So that's one way. Another way is basically using thermocouple or others, collecting the heat over there. And most interesting one is actually being able to collect the photons over there as well. So this is basically a combination of different type of technologies to bring.
Wow.
It's a matter of efficiency. It has been there, but the point was like it was quite low efficiency. We were talking about 2%. Today we are talking about opportunity of increasing it to 30%, and even in the future we may go to 60%. There was a challenge. The main challenge was the fact that these fast electrons were able to damage the semiconductor over the time. But the way we can basically avoid that is to use liquid semiconductors. They don't have crystals, so they are not damaged. And today there are lots of advancement in that part. Even AI is playing a big role in finding those advancements. And that could actually allow us to go to much higher efficiency in future.
Wow, fantastic. So you mentioned a point that I want to pick on, which is some material have the usability of 1,000 years, you mentioned?
That's right, yeah. So some radioisotopes, for instance, actually carbon-14, I'm talking about 25,000 years. But the problem over there is that the power that you have is in micro level, so it's quite low. So the longer the lifetime is, the lower power we're going to have. So that's basically the effort. But there are some other isotopes like promethium or even nickel or others, which basically can go to 100 or 400 of years. So that would be interesting.
Wow, and how does that translate to the interesting concept of a battery that you will never have to recharge?
Yeah, actually, that's the goal. So the goal actually we have right now in Vision is that we have devices that we power and we don't charge them during their lifetime. So we try to select the isotope based on the application that we have. So if you are talking about mobile phones, that's 2 years. So promethium is a very good fit for that. So we can select that and do it. I think if you go to electric vehicles, there are a couple of isotopes over there. So you're usually talking about 90 years, which is fascinating. Or when you go to defense applications, for instance, I think drones are quite interesting. And there are isotopes over there that can last for 90 days. But 90-day drone operation, which is not stopping and can go, is fascinating for this industry. So I think it's really groundbreaking, and it can shift the way that we know the energy and transform it.
That's really amazing, and we have a lot more questions in store for you. But we'll shift the conversation a little bit from the hardware aspect to the software aspect in terms of how technology is transforming energy today. And Rami, Beyond Limits, I think, and first of all, it matches the theme of the event today: beyond boundaries, beyond borders, beyond imagination, and beyond expectations. And I think Beyond Limits is a great addition to that, as long as you don't sue us for
Not
any
yet, not yet.
My question is, I think Beyond Limits has an interesting story of how it was established, how it evolved to where it is today, and how it links to space. And we would love to hear that story from you.
Sure. First of all, believe it or not, when I talk to the founders of Beyond Limits, they used similar to ChatGPT that they developed to come up with the name. So the word Beyond Limits has also been, in a way, innovative the way they used it. And if you look at Beyond Limits, primarily around 6 or 7 years ago, Caltech with the JPL, primarily they were responsible to develop lots of software and lots of AI capability for NASA.
Interesting.
And 7 years ago, there have been a decision basically how to take over $20 billion with hundreds and thousands of very high-end sophisticated software capabilities and commercialize it. So the CTO of the JPL Caltech, basically Mark James, is the founder of Beyond Limits. And you know, the whole idea, the whole concept is how you're going to be able to commercialize and make it available to the industry, to the community, the hybrid AI. And the whole concept and the whole idea of the hybrid AI, that when you send the rover to Mars and you have limited available data to build into the chip, you want that chip or the rover to be smart enough to make a decision while it's in Mars without communicating back to the Earth or without having that data built into it. So that's basically the whole, you know, the whole concept of the hybrid AI. And Beyond Limits is the market leader in that. And our core foundation is around the human, is around reasoning. Anything we do today, as a company, it has to be explainable. You need to be able to trace it. You need to be able to provide the reason behind this recommendation. And we're calling today on various tools, whether you're using the ChatGPT and others, the hallucination aspect. And ideally, you want to make sure in the industry, in the space we're in, we address that in a way that we are able to explain it, we are able to trace it. So Beyond Limits is basically around building the capability around the hybrid AI, and at the same time, making sure everything we build, everything we provide is simple. It's simple in a way that you don't need to have an AI engineer to do coding. And that simplicity and that ability to make us more control of our destiny will enable us to provide more cost-effective, more available technology and reasoning. It doesn't need to be inside NASA. It doesn't need to be only for rover. It has to be for the industry we are in.
Fantastic. I really like the human-like reasoning aspect and having traceable evidence that substantiate the recommendation that the machine recommends. And I think that's going to be key, especially when you talk about decisions that are going to impact high-value assets, whether it's within the oil and gas, power generation, aviation, or any other industry that has high-value assets. you would need to have a little bit of, I want to call it trust in the machine's recommendation. So the reasoning aspect, I think, bridges that gap of trust and enables humans to take a decision with more conscious and approach and with more confidence.
And I think, Raif, let's assume you walk into this venue, this hotel. You need to be able to say, what's the safety precautions? What do I need to do? You need to be able to ask, even if it's first time, and it needs to provide you the details, need to provide you manual. And then if you see something, you need to be able to enter your inputs. To your point, what you said is right on. But I think also the enablement for you to add, provide more analytics, more data, that's going to help us to keep improving the tool rather than to be generic. Because today, the unexplainability is one of our biggest challenge in everything we see.
So a necessary factor is complementing the machine's capability with codification of human knowledge.
Absolutely. And then you need to be able to see the PDF, the document, the manual, because I need a proof. I need to feel confident whether you are in the finance, in the industry, in a government, and the better. You need to have that visibility to feel confident that this recommendation is supported. And with time, I believe you're going to see more and more of us moving into that, and it will be more reachable and more simple as we go forward.
Fascinating story, and I hope you break this technology into so many other sectors other than space, and I believe you're doing so already. Nima, I'll shift back to you, and we'll go back to nano-diamond batteries. And we spoke about the concept, the possibility, the potential. I want to ask about how far is this technology today from mass production? Are we going to see it in our devices, in our vehicles, in our machines today, tomorrow, 10 years, 100 years in the future?
Our cars?
Yeah, usually like when people give promises, it doesn't happen. So I remember Jeff Bezos doing the, okay, but in general, I think based on the plan we have, we are thinking we can go for mass production in about 3 to 4 years from now.
Wow.
But it doesn't mean it's going to cover all type of applications. So if you're trying to think about electric vehicles, I think there is public perception over there which plays a big role. The regulatory regime which is existing is quite important as well, so we need to comply with a lot of them, even though some standards are in place, some are not, so we have to be licensed for it, so these could take time. But some other applications, I think it could be quite sooner than that. So when we are talking about, for instance, different type of IoT devices or sensors, I think that could be quite fast. If we are speaking about space applications, that could be fast. And defense sector could be quite fast. So I think that's the main point. But for some other type of applications, maybe we need 7 years from now to get there.
Wow. And is this creating a new segment or sub-segment within the energy storage space, or is this set to replace the standing technology of lithium-ion batteries?
Yeah, so interesting part is our type of technology is constantly generating. So from the day that it's manufactured, it's generating and it's being consumed. So that's one of the main differences we have with lithium-ion batteries. At the same time, lithium-ion batteries potentially have same amount of, or sometimes more power density than our batteries. In some cases, we have more because of the different type of isotope. But energy density or longevity is the one that we are focusing on, is competitive advantage. But alongside that, what is interesting about our type of technology is that there is no carbon emission out of it, and manufacturing of it has very limited amount of carbon emission as well, while lithium-ion batteries has a lot of that when you're trying to produce it. In addition to that, we are not using any toxic materials. We are not doing kind of like what lithium-ion battery is doing, so you have cobalt over there, is quite toxic. And more interesting to those factors, the fact that technology that we have could be basically completely sustainable. So that's very interesting, and I think as alternative energy source at the moment could be a factor that it can basically over time shifts into something which is can be used every day and inside the different applications.
And what's the most prominent application that you would see for this technology? Today, at least.
Today, so as I said, I think IoT and sensors, space applications, and defense industry are very interesting for it. I really like to see it one day in our mobile phones, for instance. I think that would be very exciting. I know technically it can be happening. We have regulations around sealed sources, which actually we follow those standards, so there should be no problem in that case. But still, I think the public perception is going to be there. We have to work with regulators to bring it to that market.
Wow, fascinating stuff. Rami, I'll go back to you and go back to the energy sector. And specifically, when we speak about energy, there is always the matter of cost efficiency and the competitiveness of the different energy sources when it comes to price. And what that basically entails is accessibility to users, right? And technology must have helped drive the efficiency of energy production down. But what are the main prominent areas or use cases that you believe either have helped in the past or are going to help in the future in optimizing and driving the cost efficiency of energy consumption further down?
I think, first of all, historically, it's been a common practice to have a spare engine or a spare pump, because people always like, if something happened, I need to have a spare machine. Now with the advanced technology, with the ability to have a better job in managing the supply chain, in making sure you have more advanced analytics, you see today that operationally everything is driven with more efficient and more reliable. And we have seen lately a big transformation into sustainability, into renewables, and you have seen the aggressive even cost reduction when it comes to solar and other. And that, in a way, is driven by the ability to manufacture faster, leveraging the robotics capability, using lots of analytics, lots of software, improving quality aspect. And I would say across all of the spectrum, the software and the AI capability is fundamental for that energy saving and for that manufacturing efficiency and our ability even to continue executing what everyone has said from a CO2 reduction or carbon capturing and so on. So in mine or energy storage. So all of that is going to continue and transforming when it comes to the energy sector. Add to it that by nature today, as we go and we add another 1 billion species to the planet, we have an obligation to make sure also we have more efficient way of the way we're running our life. I have seen today one of the colleagues here today, one of the startup presenting the app of better knowledge of your power consumption. That by default is going to be embedded and normal in everything we do and in everything we're managing our life. I think also today, part of what we are executing with like Saudi Aramco, we are Saudi Aramco partner, and we have the Aramco AI corridor for the entire Aramco, which is primarily connecting California with Saudi and building this AI capability. One of the key pillars that we're focusing on with Tariq and with Saudi Aramco is the whole energy efficiency, but also the whole optimization of the operation as we go forward. And that have to be by embedding the knowledge they have built over the last 70, 80 years into the chip, into the way they're operating in order to have that, because 1% is a huge savings, a huge difference.
Absolutely, and I think that's going to be a huge competitive advantage to large energy operators.
Absolutely.
Nima, in terms of energy access, you talked about solar and renewables and how they may be affected by the factor of intermittency, right? They're not available all the time because there is dependency on what the weather is like on that particular day or that particular week. Whereas nano diamond batteries, the energy is steadily available. So in those specific, and you know, you can, if you talk about energy consumption or power consumption, usually the tricky part is the peak demand, right? So the base demand can be covered with a multitude of different sources, but then if you have a surge in demand in a given time, usually this is during the summer months, for example, then the cost of producing energy is a lot higher than what it is for the base demand. So would we see nano diamond batteries in the future being utilized as a reliable and readily available source that provides a steady, constant stream of energy in order to balance the supply and demand and the base and the peak demands?
Actually, very interesting question. To give an answer to that, I should say, in short, we can say that this type of battery could be possibly a backup system for some type of technologies like solar. So when it's not working, you have this backup system over there trying to fill up the energy storage devices that we have. Yes, so in that case, it could be. Alongside that, the energy dependence could be on other type of sources could be less in some cases. For instance, if you consider your devices have integrated power that doesn't need to be recharged during the time, so you're taking a lot of consumption off the grid. So that's something which is happening. If one day this type of technology can go into electric vehicles, the interesting part is that it's constantly producing. So you can plug the electric vehicle back to the grid and provide energy back to the grid. So that means you can supply. And it's going to be decentralized supply to the grid, which is quite interesting. So you can take away a lot of costs, which is happening in general to have a long grid and take those around. And the power, basically, efficiency is going to increase in that case. So in short, I should say the answer is yes, there is such possibilities.
Fantastic. I think we're reaching the last 2 minutes of our discussion, and I'm thoroughly enjoying it. Concluding words to leave us with, Rami, your outlook for the future and how you see AI playing a role of it, and how you see individuals and enterprises adapting to it, dealing with it, embracing it.
First of all, I want everybody to realize that everything the company is doing and everything you see around you, the human factor will not be replaced by AI. People thinking that the more we implement, the more we move AI, there is going to be this negative impact on the human. I would say it should be the opposite. And my view, the more the hybrid AI and the more knowledge embedded there, you're going to see the human factor in the center of everything related to the AI transformation. It will not and it cannot replace the human factor. The other piece, just the same we experienced in the last few years, the entire transformation for our cell phone devices versus where we are right now, you're going to see on a faster pace everything related to the chat GPT, everything related to the AI, to the cloud, and so on. But we as a region, as companies, we ensuring that all the knowledge we need, that it's in the brains of people who have 4 years experience and so on, embedded into the way we're operating, and we are protected from any, I would say, outside factor, because cybersecurity is fundamental. So you're going to see fast moving with these two things basically monitored carefully as we go into that. But hybrid AI and AI transformation will never replace the human knowledge. It have to be a center of everything we do.
I think that's a positive outlook. A human factor is key, and technology complements and enables the human capability to.
Absolutely, absolutely.
Fantastic.
Yeah.
Nima, same question. Your outlook to the future. What do you think is next for nano diamond batteries?
I think Rami actually pointed very well. So AI is a tool that could really help the advancement in materials. And that's where energy storage devices right now are going. So you have a lot of advancements over there, and a lot of different solutions are coming. For instance, I heard Stila Nano made a contract with Panasonic, or steel oxide energy storage device, and so on. But I think the most important factor that we have to focus on about the future of this solution is the sustainability of them, environmental friendliness of them, and in general the impact they have in on the environment. So those are really important factors that we have to look into. And that basically requires a collaborative effort between governments, big corporations, and even the funding sources which are existing. So the way that this market is going to be moving, I think, is really dependent on these factors. And without them, I don't see a bright future, but I'm quite optimistic at the same time.
This has been an amazing discussion. I wish we can stay longer and converse. But Rami, Nima, thank you so much for joining us today.
No,
and
thank
you
you
for joining me in this.
Thank you so much.
Congratulations. Very well event. Thank you. Very
Much
proud.
appreciated. Thank you for your participation.
Thank you so much.